Sir, am I audible, sir?
Yes, you are.
Thank you so much, sir. Good morning, sir.
Good morning, Dr. Chawani.
Sir, I shall introduce you and then we shall begin with the session.
Yes, sounds good. Ma'am, sorry, we are unable to hear you. At least
Okay. Thank you so much, sir. So I shall begin again. I welcome you all to this final day of 1 week online short-term training program on water quality quantification, restoration and environmental conservation of existing water bodies, Module 1, that is sponsored by AICTE and organized by the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. So we are fortunate to have with us Mr. Priyanshu Kumath, sir, who is the founder of founder and CEO of Clean Water Sustainable Technologies Private Limited. Presently, he is working with the Credit and Risk at Drip Capital Mumbai. He has also been working as a consultant for establishment of wastewater treatment plants, STPs, ETPs to tackle problem of water pollution and water scarcity. Presently working in 10 cities. He has also worked as a senior manager operations, teacher training and recruitment at White Hat Junior. He has also been working as an analyst at Lysis for Us and a graduate in civil engineering from IIT Bombay. Thank you so much, sir, for accepting our request. And I request you to please start with the session, sir.
all right. Thank you. Good morning, Dr. Devanshi.
Good morning.
Good morning, everyone. It's a pleasure to be here, pleasure to be talking to you this wonderful Saturday morning, and thank you for showing up, everyone. Yeah. So let me share my screen before I start. Dr. Jagwani, I'm unable to share my screen. Could you check, please?
So from my side, I have made you presenter, sir.
All right. Just give me a minute, please.
Sure, sir.
Okay, I'll have to quit and rejoin for the.
All right, sir.
Am I audible?
Yes, sir. Now you're audible. Sir, now can you share the screen? Is it coming?
Yes, I can. Let me know if you can see my screen.
Yes, sir. It's clear and absolutely visible.
Great, thanks. So, all right. Good morning, everyone. So I'll start presenting. So before I come to basically what I'll be presenting today, let me just give you a brief snapshot of what it is going to be about. So this is going to be about, as the overall lecture series is about, basically restoring water bodies. And the unique product that we have is floating islands, also known as floating wetlands technically. So just to give you a brief snapshot before I begin, before I basically come to our product and what we've been doing and how we restore water bodies, let me give you all a brief introduction about myself. So I am Priyanshu Kumath. I hail from Indore, Madhya Pradesh. I am actually an IIT Bombay alumnus with a BTech in civil engineering. I worked with a couple of civil engineering real estate organizations such as Godrej Properties, Lysis Forest, before joining a startup called Housing.com in the real estate space. Was a great experience for me. Got to lead a team of 700 people there at the tender age of 25, which was a great experience for me. Which gave me the confidence that I can start an organization myself, which I did. So I moved back to my hometown Indore, started Clean Water back in 2016. So we started with a so we started basically with the vision to solve problems in the water sector. Also setting up sewage treatment plant and other wastewater treatment plants. And over time, so we started with the services-based approach, and we over time added a product-based business model as well of restoring water bodies. Uh, yeah, so that's a brief about me. Anyway, so basic things. So our organization is called Clean Water. That's our brand name. We're registered as Sustainable Water Technologies Private Limited, and Floating Islands is our product. So till now we're present in about more than 12 cities, signed more than 30 projects with, including private and government projects, registered in Startup India MSME, general stuff. Yeah, I'll move on. So basically we started our journey with building sewage treatment plants. Just a few photographs from a site. So we began by giving services of consultants and contractors, providing designs to build up these civil works and also the electromechanical installation to get the STPs up and running. So that's what we started our journey with. I'm sure you all must be aware about sewage treatment plants, but there are these two technologies that I'd like to particularly bring your attention to. So besides this, we have worked on conventional technologies such as MBBR, SBR, like the aerobic technologies and all. But this DBAT system is something we thought was really great. So this cylinder that you see is the vortex is the final module of the DBAT system. So that's one of the technologies that we were working on, building sewage treatment plants. This is primarily an anaerobic technology with a settler, anaerobic baffle reactor, anaerobic filter. One of the older versions of this technology happened to have a planted gravel filter. I'm sure given the elite audience present here today, all of you must be aware of what a horizontal planted gravel filter looks like. So these are basically gravel beds which have plants planted on top of them, very shallow gravel beds. And so basically this is the final part of the sewage treatment plant for use for polishing water and further treatment. And practically this is how it looks like at the site. So this technology of cleaning water has existed forever, of basically cleaning water through plants. What we did was we basically applied the same concept and productized it. We basically made a floating version of the same technology, right? So how do plants clean the water, right? So the plants and the gravel, also known as maybe matrix or biomedia, present underneath the islands, together help clean the water. So what happens is basically friendly bacteria called biofilms would come and attach to the long plant roots and on the island material. And together, these bacteria and the plants would take up nutrients from the water. They would take up nitrogen and phosphorus compounds such as ammonical nitrogen, nitrates, nitrites, phosphates, phosphites. Also ensuring the dissolved oxygen goes up in the water, as well as the BOD, COD gets reduced as well. A lot of heavy metals also get pulled in by the plants. So that's what we did. We took a very simple concept from sewage treatment plants and we made a floating version of this. To give you more brief, let me show you a quick video. Let me know if you can hear the audio. Ecosystems in the world. Are you able to hear the audio?
Rivers, yes, sir.
Marshes, and wetlands are essential for survival of humans. But they are in a crisis. Water is disappearing, and the rest is getting polluted. So the ecosystem is restore and maintain floating naturally quality and providing ecological habitats. Floating islands mimic a wetland-like effect to clean the water body. Underneath the island, friendly bacteria begin forming biofilm on the long plant roots and on the island material.
Yeah, so this is one of the things that we did. Besides having just floating plants, we've added a lot of biomedia, which a lot of you would have seen in MBBR-based sewage treatment plants. So we added a lot of biomedia underneath the islands, so that more and more biofilm formation can happen. So these are basically bacterial colonies or bacterial films, which would come and attach to the plant roots and on the biomedia. So this is how we ensure that maximum water treatment happens.
Island is designed to maximize microbial activity, helping to settle sediments and uptake phosphorus, nitrogen, and heavy metals for cleaner water. Biofilms are eaten by small organisms, which are eaten by fish, which are harvested out of the water by birds and humans. Thus, floating islands clean the water, restore the ecological cycle, while beautifying the surroundings at the same time. Floating islands are available in different product variants and can be applied in a variety of manner to suit multiple needs. For more information, visit floatingislands.in.
Yeah. So this is a brief about our product. Also, a general thing for the entire, I think, 1.5 duration. If anybody has any doubt, please feel free to unmute yourself and speak up. It would be good if you guys keep asking questions in between, so that I don't have to speak for the entire 1.5 hour duration. So please feel free to ask any questions. So this is a brief about our product, floating islands, and how we restore water bodies through it. I'll basically come to a different dimension of this and circle back to the original point. So the graph that you see here on the screen is about a adoption of any new technology or product that comes in, right? So if any new technology or product comes in, it first goes through the R&D phase. Then it gets launched where the early adopters kind of adopt the technology. After that, there comes the growth and maturity stage where the majority of the population or majority of the users adopt that product or technology. And then there are these laggards, the last 10, 15, 20% who are the last one to adopt any technology. So comparing that in the water sector, what we thought was basically water treatment or drinking water is kind of available to almost 70, 80% of the population of India today. So that has kind of matured. You see, we have ROs and aquaguards in almost every home or commercial establishment. So that sector has matured. In terms of water infrastructure, in terms of the drainage pipeline, the stormwater pipelines, they've kind of reached at least 50% of the urban areas. So it's on the growth stage. The wastewater treatment sector of setting up sewage treatment plants, effluent treatment plants is still in the launch stage, right? So the government claims basically 25 to 30% of the wastewater is getting treated. So it's still on the launch stage. But when you think of the sector of restoring water bodies, it's still in the R&D stage. Not even 1% of the water bodies have been restored till now. So any organization that would enter this sector today could have a really great advantage in terms of applying their products and doing R&D to kind of take control of the water body restoration sector. So that's why we thought that maybe besides, so we had started with wastewater treatment sector, which was our kind of bread and butter, but over time we've also added the water body restoration sector. And since I'm from Indore and with the Swachh Bharat mission, the timing couldn't really be better in terms of restoring water bodies. Another thing that we thought was basically there are thousands and millions of water bodies out there, like right, including lakes, rivers, drains, streams, all of that. If we follow the approach of a consultant, right, we would be able to do at best 100, 200, or maybe 500 water bodies in my limited lifetime. If we kind of follow the approach of consultant, going to the sites, making DPRs, also taking up civil work, designing all parts of the water body restoration effect, that would be pretty slow to scale up. The services-based model would be slow because every water body is unique and would require unique attention. So what we thought was a product-based business approach would be far more scalable, right? For example, the manufacturer of your smartphone, they manufacture 1 lakh, 10 lakh pieces every year. They have to manufacture it singly and they can ship it across the globe, right? So that's what we thought we'd follow, product-based business approach to solve the problems in the water sector. So it's not like the government isn't doing anything in terms of water body restoration. We are trying out a few solutions, right? The first being the most obvious of setting up sewage treatment plants. There are a few shortcomings in terms of STPs. The first being there is absolutely no space available around the lakes or rivers, in urban scenario at least. We've encroached the water bodies from all sides, right? So there isn't much space for setting up there's not space for setting up STPs everywhere, let me put it like that. Besides that, it requires a huge capital investment upfront and a huge maintenance cost as well, because of which often the STPs are not running, or maybe the treated water does not fall under the guidelines. Besides this, the sewage treatment plants often let in a lot of chlorine in the treated water, which harms the flora fauna around the water bodies. We're also trying, like people around the world are also trying chemical solutions or bacterial solutions, which is not the best approach. For example, chemicals have a lot of other side effects. They produce a lot of sludge or silt. They would solve the problem of water, but they'd kill the organisms in the water as well. So we saw a lot of shortcomings in the current solutions. Just to give you an example, how we've encroached water bodies on all sides. Where would you set up a sewage treatment plant here, right? There is no space unless we establish a buffer zone around the rivers and lakes. Yeah. Another, the ecology aspect also needs to be considered where we restore water body. It's not just about cleaning the water. If it has too much chlorine and the fishes can't survive and the flora fauna can't survive, that water body is not restored according to me. So I think we have to keep this in mind as well. So with the background now set, and now that we've seen what the product does, let me kind of highlight a few benefits as well. So floating islands is a very low capital and low operation and maintenance solution, right? So this island, for example, that you see on the right of your screen, we didn't have, once we planted canna in this island, we didn't have to touch it for almost 3 to 6 months. Not even a single visit to trim the plants or do anything. Even the island does not require maintenance, and these plants are also so versatile that you won't even have to go there for 3 months or 6 months. So very low O&M, low cost. It does not require any skilled manpower or an operator to run. You need a simple gardener to just trim it every 3 to 6 months. Another great benefit of this is that we don't really require any additional space around the water bodies. We can simply float these floating islands on top of the water body, thereby, so we don't really need any additional space. It also caters to majority of the pollutants. I would not say all. It can't really take up all of the chemical effluents in the water, but it takes up nutrients, it takes up heavy metals, it reduces BOD, COD, it fixes pH, it increases dissolved oxygen. So it caters to most of the pollutants. Besides the water treatment plant, the ecology and biodiversity gets restored as well. So basically, floating islands are like a platform which provide habitat for different organisms to thrive. So we see insects and birds and snakes come sit on top of the island. Fishes would come and hide underneath the islands for shade. So the entire ecosystem is also kind of getting restored because of this. No mechanical or electromechanical components required. So great in terms of that as well. It also increases the fish population. So what we've realized is the fish population in any water body can go up to 2 to 5 times if there are floating islands there, which kind of provides economic benefits to the fishermen and the communities that live and thrive off the water body. So that's another benefit of this. And anybody looking to, let's say, restore a water body, beautify it, or just kind of restore the habitat, maybe protect the coastline from erosion, or just trying aquaponics and gardening, can try out floating islands. Other small benefits also include reducing evaporation and beautification of the surroundings. So that's a brief about floating islands. I'm sure a lot of you must be aware of Sustainable Development Goals, SDGs, as defined by the United Nations. So floating islands cater, so out of 17, floating islands cater to 7 of them. So which includes basically good health and well-being of the people living around the water bodies, obviously clean water and sanitation. So it's an innovative product in itself. It is also part of a sustainable cities and communities. It helps reduce climate action because it reduces the formation of methane, right? So when we oxygenate, when the roots oxygenate the water naturally, less and less methane gets formed in the water, and therefore it helps in controlling the climate change that we are beginning to see. Life below water, pretty obvious how it affects it, and life on land as well. So the entire ecosystem around the water body also gets affected, positively affected, let me put it that way. Any questions here till now? Anyone, please feel free to unmute yourself and speak up.
Are the participants wanting to interact, or if they have any queries or doubts? You can either type in the chat box or you can come online.
Yeah, ma'am, would the participants be able to unmute themselves and speak up, or would they be only able to put it on chat?
Hello.
No, sir, they are free to unmute.
Okay.
Sir, can I ask one question?
Yes, sir, please go.
Can you give a list of species of plants? Which type of plant can remove which type of pollutants?
Yes. So there are about 5 to 8 different species of wetland type of plants which are really good for water treatment. The first being canna that you see on the screen here. There is vetiver grass, which is also called khas in Hindi. Jo coolers mein khas ka perfume jata, that vetiver grass. There's umbrella palm. There are reeds and phragmitis. There is elephant grass. There may be a few more. Maybe if you could connect like after the call, I can give you maybe an entire list. But yeah, these are the major plants that people often use.
Okay. After that, I will contact you.
Good. Yes.
Is there any your official email ID is there?
Yeah. It's at the end of this slide. It's
Okay.
anyways Priyanshu@clean-water.co.in.
Okay, sir. Thank you.
Thank you. Anyone else? Any questions? All right. So I'll move on. So I think the audience present here
Yes,
is
sir. I
typically-
just wanted to ask you something.
Yes,
Sir, can
ma'am.
I ask?
yes.
Sure,
So,
ma'am.
like, it is in context with what that sir asked. I am interested in getting to know, like, for heavy metals, what we can use.
Yes. So the efficiency of heavy metals uptake is different for different plants. I do have a lot of technical literature as to whether, let's say, canna takes up more heavy metals or does vetiver grass does. So I can share those technical documents with you. And also in terms of heavy metals, there would be multiple, right? Lead. What is the lead uptake efficiency of which plant? So I can share that with you as well after the lecture. Please remind me at the end of the lecture. I'll do that.
Okay,
I'll share.
sir. Thank you.
That means, sir,
Okay.
every metal is specifically absorbed by different plant species, right?
I'm not sure if 100% of the metals are done, are being uptaken, but a majority of them are lead, zinc, cobalt. A lot of these heavy metals are uptaken and different uptake efficiencies for different plants, but not 100%. Not every heavy metal can be taken up by plants. Yeah, so it's not so this floating islands is a solution much suited for domestic wastewater, where we have wastewater coming in from toilets, maybe washing clothes, wash basins, utensils, clothes, etc. But for the really hard and toxic chemical effluents coming in from the industries, it cannot cater to all of them, but it caters to the majority of them.
Thank you, sir.
Thank you. Great. All right, I'll move on. So a lot of you here would be aware of how sewage treatment plants work. And most of you would be aware of the conventional aerobic technologies such as SBR, MBBR, activated sludge process and all. So you would have seen these plastic things called biomedia, right? So what happens is in an aerobic reactor where we are kind of pumping oxygen through blowers artificially from outside, we put in the biomedia in that. And so biofilms like this would come and attach to the biofilm on the inner side, on the outer side, everywhere. So that is why this is being designed this way to provide maximum surface area. And that's how aerobic sewage treatment plants treat the water, right? These bacteria would eat up all of the pollutants in the water and then produce sludge. So we took the similar concept of how basically the plants also do it, but also how biomedia can also contribute to increasing the efficiency. So that's what we did. So we added biomedia underneath the islands, and on if we add a different matrix material on our island as well, we see a lot of green biofilms also come and attach to the islands because now they have a surface that they can attach to. There are few bacteria that can remain suspended in the water without having to have any surface to attach to, and they can still thrive. A lot of these actually thrive if they have a surface that they can come and attach to. So that's what we're doing effectively. The long plant roots and the biomedia, all we're doing is giving more and more surface area so that more and more bacteria and biofilms can come and attach, and therefore more water can get clean. So that's the same water treatment principle that we picked up from STPs and applied here on floating islands. So if we add aeration underneath the floating islands as well, the treatment efficiency of water goes up multiple folds, right? If we're not adding aeration, there's this aerobic zone near the roots as well. Then there's an anoxic zone where there's insufficient oxygen, and at the bottom of the lake or the river, there might be a completely anaerobic zone as well. But what you've noticed is if we add external aeration, the water treatment efficiency goes up multiple times. Yeah. All right, moving on. So let me put this from a very different perspective of how floating islands clean water. So this is a lake that we restored. This is the same lake. So the problem that happened here was any leaves and branches that would fall in would decompose, rot, and make the water green, right? Because then the algae, there are two types of algae. This is duckweed that is forming on the surface, and then there's this dissolved algae which is providing the water a green tinge. So this algae would then come in the water, eat up all of these decomposing, rotting organic matter and multiply, and then basically populate the entire lake, and then the water would turn green. Effectively, what we're doing from a very layman perspective is we're introducing a bigger organism in the water, right? The same food source is available for algae as well. And so we put in a competitor for the same food source. All of these biofilms and plants are, particularly the plants are a bigger organism as compared to algae. So they would compete with algae for the same food source. And eventually the plants would uptake all of the nutrients, and there would be no nutrients or no food left for the algae to eat and multiply. So what floating islands do is basically they eat up all of the nutrients, and then algae has no food. So algae starves and eventually begins to recede from the water bodies. And over time they disappear, or they might be left in a very small corner at the beginning of the lake, but eventually they kind of completely vanish from the water body. So it's as simple as that. You have put in a competitor in the water body which would eat up all the nutrients, so that algae gets completely vanished from the lake. So they have no food left for them, and they basically die and move away. So I think that's the first benefit of floating islands, is the water treatment part. The second is the ecology part, right? So these are islands from across different sites that we planted. So this is from Sabarmati riverfront in Ahmedabad. These two pictures, we see a lot of bagule, a lot of birds come and sit on top of this, right? Because there are a lot of insects in the soil and around the plants, and also the island acts like a very good platform for the birds to sit on and hunt for fish underneath the water. So they have improvised as well. This is from Delhi College, Indore, where a lot of ducks enjoy the island and swim around it. This is the same island from Delhi College, where we have a water snake, a non-poisonous water snake on the islands. Birds on different sides as well. Fishes would come kind of near the islands. So let me show you a quick video in terms of the ecology part. This island was for beautification purposes only. This is not for water treatment, given the type of species of plants that we've planted here. But anyways, it does help to restore the ecology. Thought would mention that. So this has flowering plants which don't really clean the water, but this is for water treatment. This is vetiver grass that you see on the island. You see different insects, fishes on the island. Then there's this turtle in one of our sites in Bangalore. It comes and hides underneath the island. This is that snake, non-poisonous water snake I was talking about. So this is that Pipliyapala Regional Park. This is that Sabarmati riverfront again. So how the fishes use it is pretty awesome, right? So because fishes are in the water body and they have no shade from the sunlight or predators. So if you put in a floating island, they would come and sit underneath the island, because then it provides them protection from the predators. It provides them shade from the hot sun on certain days. And also the biofilms that form underneath the island are a food source for them as well. So we see a lot of fishes swarm around the island. That's a great sign to see. And then everything in terms of ecology falls into place once things start. So the third benefit is the beautification. So we made different islands. So these are canna, that are wetland plants that clean the water. These two are islands that even this third, where we can plant like flowering and beautiful plants as well for those people who whom the water body is clean and they just want to beautify it. Floating islands can be used for that as well. So all we're doing is we're providing a platform which plants to plant on top of it, and for which purpose do you want to use it? It's really up to you. This is at Sabarmati Riverfront. This is at a government campus in Indore. Yeah. Moving on.
Indore.
Yeah. So I've shown you what are the different benefits of floating islands. Let me now come to a lake that we restored in Indore.
इंदौर इंडिया के सबसे स्वच्छ शहर ने अपने लेक रिस्टोरेशन इनिशिएटिव के साथ अब एक नया एग्जाम्पल सेट किया है। पुलिस ट्रेनिंग कॉलेज मुसाखेड़ी के नालंदा सरोवर को एक नई लाइफ दी है टीम क्लीन वाटर ने, एक नेचुरल और इको फ्रेंडली प्रोडक्ट फ्लोटिंग आइलैंड्स के साथ। क्लीन वाटर के फाउंडर प्रियांशु कुमथ IIT बॉम्बे से पढ़े हैं। उन्होंने जब इस लेक का सर्वे किया तो पाया कि लेक में लीव्स और ब्रांचेस आकर गिरती है और फिर उसी में डीकंपोज होती है, जिसके कारण एल्गी फॉर्म होने लगती है। इसके लिए उन्हें पता था कि फ्लोटिंग आइलैंड्स ही बेस्ट सॉल्यूशन होगा। फ्लोटिंग आइलैंड्स पानी पे फ्लोट करते हैं और इन पर प्लांट्स लगाए जाते हैं। इन प्लांट्स की
this is umbrella palm, this is vetiver grass.
पर प्लांट्स लगाए जाते हैं। इन प्लांट्स की रूट्स पानी में जाती है और आइलैंड्स पर जमे फ्रेंडली बैक्टीरिया के साथ मिलकर पानी के पोल्यूटेंट्स को खींचती है। ये वेटलैंड टेक्नोलॉजी एनवायरनमेंट फ्रेंडली और लो मेंटेनेंस भी है। लेक पर एक बायोफिल्टर और वाटरफॉल भी
Yes, so this is another improvisation that we did at the lake. We thought that the water in this lake is going stagnant, right? Because it's a lake, it does not get circulation or get oxygenated very often. So what we did was we made a biofilter and a waterfall combined. So we'd pump the water from the lake, pass it through this biofilter, where there are biomedia and a physical filter as well. And then the water would fall back again into the lake through this waterfall that you see on the left. So it's a twin solution in itself. So the biofilter that you just saw is buried underneath this. There's this pump which would pull the water from the lake, passes through again in the lake as a waterfall, ensuring aeration and oxygenation as well. So this is another intervention that
oxygenation में help करता है। लेक में पानी क्लीन करने वाली फिशेस डाली गई है। साथ ही लेक की बाउंड्री पर ट्री प्लांटेशन और ब्यूटिफिकेशन किया गया है। लेक रिस्टोरेशन के बाद कैंपस के रेजिडेंट्स वहां टाइम स्पेंड करने आते हैं और साथ ही साथ लेक पर बगुले, टिटोरी, मोर जैसी भी बर्ड्स आने लगी है, जो कि नेचर का इंडिकेशन है कि ये प्रोजेक्ट सक्सेसफुल रहा। इंदौर जैसे शहर, PTC जैसे कैंप।
So this is the lake that we restored. Yeah, and this is how it looks right now from a bird's eye view. We were very lucky also to get the award of Water Hero from central government, Jal Shakti Mantralaya, Water Resources Ministry, for this lake restoration project that we did. So yeah, this is how it looks. Just wanted to give you a brief of that. So any questions till now, please go ahead. I'll take a pause here.
Are the participants having any questions? So I would like to ask.
Yes, please go ahead.
So what's the basic medium over which these floating islands keep floating? Like,
how do they float?
Yes, sir.
Yeah, I'll get to that. I'll be covering that in the upcoming slides here. All right, so I'll move on for now. I'll cover this question of how floating islands are made. So in the coming slides. So now, how to put islands in a lake? Should we just scatter them? How should we do it? So basically, the picture on the left is one of the designs that we created, where you could maybe quadrant off a section of the lake. This happens a lot in Bangalore Lake. So if you would have seen, if the inlet is coming in from here, they would make a stone wall or a gabion wall something like this, like walls made of boulders, so that water can still pass through them, but it still creates a different section. So near the inlet, if we do a lot of aeration and floating islands, even if there's sewage coming in, the treatment can happen here. All of the sludge that gets produced can get clarified or get settled at this wall or at this juncture where you've created a separate wetland area at the lake. And the major part of the lake or the water body can still remain clean. So all of the treatment can happen in the smaller area, and the bigger lake can be enjoyed by everyone. How to do that? So for complete water treatment, we would like to have anaerobic, anoxic, and aerobic conditions, all three, where there is no oxygen, part oxygen or inadequate oxygen, or completely aerobic zones where there is a lot of oxygen. So all of the three stages would ensure that entire treatment happens. And the clarification, by clarification, we mean settling of the sludge at the check dam or this Gabion wall, so that all the sludge that gets produced gets settled here. Only the clean water kind of goes into the main lake. That's how we can do it. The picture on the right is another design. I'm sure a few of you must have heard of Mr. Anand Malligawad. He's a lake conservationist based out of Bangalore. So this is what he created. So he was also from the inland. He's creating a settling tank, a tank with boulders and plants on top of it, then a section for floating islands. So different floating islands can be put in near the lake boundary where the water is most dirty, and a few can also be put in between in the center of the lake. So different ways you can put it. Yeah. After lake restoration, let me come to the point of river restoration. This is not one of our projects. This is a project in the Philippines, actually, where a river similar to how we see urban rivers in our cities, a typical river with pollution, a lot of pollution, sewage, a lot of trash, can be transformed into this using floating islands and maybe aerators in the middle as well. So yeah, even rivers can be restored. Obviously, we need a lot more area because of the flowing water. We need, let's say, 100 meters, 200, 300 meters, depending on the flow, the depth, water quality, and all of that. But before I come to more details about river restoration, I think the major challenge that I see in India today in terms of river restoration is establishing a buffer zone around the rivers. So let me talk about the Kanha River that flows in Indore. So all of its tributaries, etc., combined, they flow for more than 22 kilometers, right? And the encroachment on all sides is worse than what you see here. A lot of the balconies of people overhang on the river, on the Nala drain, whatever you want to call it. So if you don't have a buffer zone, so by India government rules, there should be a buffer zone of 100 feet or 30 meters on either side of the river. But we don't really practically see that happening, right? Because I did my calculations. If we want to have a 100 feet buffer zone on either side of the river, we might need to move about 1 to 5 lakh people. Out of a population of about 30 lakhs in Indore, we might need to move 1 to 5 lakh people. And in India, that won't happen, right? If you would go ahead and ask people, do a survey asking people to get maybe relocate them somewhere else, it does not happen in India, right? A lot of local politicians, leader would come in here, say this cannot be done, vote bank politics, all of that. So I think that is the major challenge that we're facing in terms of river restoration right now. Because if we are able to clear this area, establish a green buffer zone, everything else would fall into place, right? Because if you've relocated the people living near the water bodies to someplace else, there would be a lot of more pressure on the government to do something more about it, right? After the people have moved, you just need to put in all your effort, establish STPs, floating islands, plant trees, etc. So I think that is the major bottleneck in terms of river restoration in India. Once we do that, I think we have technical solutions that how we can restore them. So let me come to the process flow of how I think a river can be restored in India. The first part being a floating solid waste barrier. let me show you what that is. So these are basically floating barriers which can help collect solid waste. These absolutely need to be put on our rivers because we also dump a lot of solid waste in the rivers. So at least the floating part can get captured here. Any solid waste that is on the river bed on the bottom of the river would obviously still pass through, but that would get collected at the check dam. So I've kind of considered that as well. So we can remove all of the pollutants, the floating pollutants, solid pollutants here itself. The second step would be to ensure aeration. Because of a lot of sewage coming into the water bodies, the oxygen level goes down to zero in most of the water bodies. So what we'd have to do is provide external aeration. Either if in your geography, if there is a lot of gradient where we could have a lot of waterfalls to ensure aeration, that'd be better. But in a plain area such as Indore, where there's just a drop of 3 to 4 meters from one end of the river to the end next, right? Like for that 22-kilometer stretch, I don't think so. It falls for more than 4 meters. That's not a big gradient. So natural cascading aeration cannot happen, at least not in Indore. But if it can happen in your geography, I think that should be step number one. Otherwise, we need to do external aeration, floating aeration, because if we want to aerate from the bottom, a lot of stones, boulders, a lot of other solid waste would come and harm the diffusers if we try to aerate from the bottom of the lake. So that's why we need floating aeration. But for floating aeration, again, we need a depth of at least 3 to 6 feet. So then we'll have to make a check dam so that there's at least a water depth of 3 to 6 feet, right? Because most of our rivers, we see there's a water depth of just 6 inches, 1 feet. So we'll have to make a check dam so that at least 6 feet of water is collected. So after collecting the solid waste, the second step is aeration. The third step would be to put in floating islands. So they can be put on the sides along with the river walls or the embankment walls, or they can be put in middle as well. If we put them in the middle, particularly at the times of monsoon, the flow is very strong, and we might need even stronger anchoring. So maybe on the sides is better. Maybe the aeration can be done from the middle. So there's a lot of way how we can do it. Maybe we can put in not like we can put in floating islands not in the direction of the river, but let's say perpendicular to it, so that the water passes through it. So there are different ways we can go about it, and can be very beautifully integrated in the urban landscape as well. So this is from Korea. These are not floating islands, which I just wanted to give you a sense of how they can be integrated. So we can create then walkways and other urban infrastructure around it, and the river looks great. Yeah. So after solid waste, aeration, and floating islands, the fourth step would be to create a check dam. So the check dam would ensure that there is at least 3 to 6 feet water depth, so that floating islands can float, floating aerators can float and do their job. So that's why we need a check dam. One of the features that we can integrate with a check dam are piano weirs. So you see very oddly shaped weirs that you see here, kind of like piano keys. So what this does is, had it been a straight line, the area available for water to overflow from the weir would be less. But if we have piano shapes on the check dam, it gives a bigger surface area, so that if there's a lot of sudden rainfall upstream and a lot of water is coming downstream, the water flow can get regulated. It also helps to control the basically water flowing downstream. So piano weirs could be a great idea of integrating with the check dam. And so all of the silt, sediments, rocks, small rocks, all of the solid waste would also get collected at the check dam, right? All of the floating ones had got collected earlier. All of the waste that is flowing attached to the river bed would come and accumulate at the check dam. So what we can do is maybe we can just pull that out and compost it, right? So because it has a lot of fertile sludge and a very fine sediments and soil, right? Otherwise, during the monsoons, your fertile soil would go wash away, go downstream, and you'd never get it, right? If you capture it at the check dam, send it back upstream where it could be used again, this fertile soil, we can maybe conserve the fertile soil in our geographies as well. And anyways, we had to clean the check dam, so I think this can be put to good use that as well. So this is how I propose that rivers can be restored. If the water is really, really bad, maybe we can add another step to it, maybe adding other solutions such as maybe herbal extracts of ashwagandha, tulsi, all of that. We can do that. So every water body is unique, and the solution would have to be customized for every river as well. Yeah. So before I move on, any questions till now? Please go ahead. Anyone, any suggestions or any questions or any doubts? Please go ahead.
Sir, good morning.
Good morning.
Sir, this is Vignesh Bharti from Tamil Nadu. So I have one small doubt, sir.
Yes.
Sir, how about the stability of this structure, sir?
Stability of floating islands in rivers, are you talking about that?
Yes, sir.
Yes. So please go ahead.
No, sir. In case of some natural calamities like flood or other problems, how will it react, or how about the stability conditions?
Yes, a very good question actually. So this is something we've done and we have learned by implementing floating islands at different sites, right? So we have the first islands that we made, we installed on a lake, and they were okay, right? Because there's not a lot of flowing water in lakes. But when you go to rivers, it's a different scene altogether, right? During the monsoon, there is so much flow that the islands need to be really strong, and anchoring floating islands in the river cannot happen from the bottom. It has to be done from the sides. And then this needs to be so strong that they don't get washed away during the rivers. And we ensure that. So I'll be covering that as well in the coming slides. Just hold on. So I'll be covering that. I'll answer your questions there.
Thank you.
Any other question?
So anybody else who's having doubt, they can unmute, or if they want, they can type in the chat box.
All right, I'll move on for now. So there are a lot of things to be done in the water bodies, but we are trying to kind of limit our focus to manufacturing floating islands. We do provide consulting as well for now, but our strategy for a long term for restoring thousands and millions of water bodies out there is to take a product based approach or a manufacturing based approach, very similar to pump manufacturers such as Kirloskar, right? So Kirloskar makes pumps of 1 HP, 5 HP, 10 HP, right? Set specifications. And Kirloskar would not go and apply to, okay, so since restoring water bodies is a completely B2G segment, right? It's not a B2B or a B2C. Water bodies have been owned by the government primarily, apart from a few private water bodies. It's been primarily owned by the government. So it's a B2G business segment. So you'd know that, right? Kirloskar would not go to every government department and file tenders, right? So that's how we want to do. We also make islands of similar 1 meter by 1 meter, 2 meter by 2 meter, 1 by 2 square, rectangular, circular. And similar to Kirloskar, we have our distribution channel we would like to give. So we would like to stick to manufacturing, give our islands to the distributors who could kind of then supply to each geography or each government department, so that we can keep our focus on making the islands better, bigger, stronger, better quality and all of that. And the distribution, because the distribution has to be done throughout India and globally as well. So establishing a distributor channel similar to Kirloskar makes sense for us. And we stick to basically manufacturing, making islands better. The distributors take the islands from us, supply to the government, also take care of the installation, right? Putting in plants and soil on top of it, attaching ropes to it, and then just anchoring it on water and maintaining, if whatever little maintenance it requires, our distributors can take care of that. So we are also following a similar business model so that we can actually cater to the thousands and lakhs and millions of water bodies out there. As consultants, we'd be able to reach 100, 200, 500 water bodies at max, because then we'll have to give very detailed attention to each water body, then which kind of limits us to the number of water bodies that we can possibly reach out to. So that's the method that we're taking. Yeah. So I'll show you our island journey. So these are the first 3 test islands that we built. The absolute first was made of thermocol, because this was the first try. The second one was made of plastic pipes. You would have seen those 4-inch PVC pipes on the exterior of buildings, bringing the sewage and water down, right? So a structure of that covered through a carpet-like material and having like material in between so that we can plant plants on top of it. And this was made of polyurethane foam. So 3 different materials we tried out of our first islands. Different learnings. For example, the pipe that was inside this developed a small leak. So then the entire buoyancy of the entire structure got compromised, right? Because if there's air in the entire thing, it would float. But sui barawar ka bhi chhed hua. Even if it develops at the tiniest of holes, right? That buoyancy is compromised and it would sink. So we had added plastic balls inside those pipes so that even if a leakage occurs, the plastic balls would still keep it afloat. So these were our first test islands. We took a lot of learning from them. We installed it on Harsola Lake. This is at near Rao in Indore. Post, we made a different, very marketable, very beautiful product. So this is finished with Rexine. This is polyurethane foams. And the structure of this is made of aluminium. So this is 1 meter by 1 meter. Ideally, it can take up to 80 kgs, including its own weight. So ideally, we should just be loading 40 kgs, 50% of what it can take. So with soil plants in its own weight, I think it takes about 40 to 50 kgs and still float. This is when we had planted it on fresh water. We took up this island from here, put it in a sewage pond, and the islands grew tremendously. You can see. So the length of these plants had gone up to 7 feet as well. And we didn't have to touch it for 6 months. So low maintenance, we did not have to touch it for 6 months. We also saw a snake sitting on this island sometimes. So yeah, great different learnings when you implement on the site. From this, we made an even stronger product. So this is 1.2 meter by 1.2 using different materials. So this also has a continuous planting area. This is perfect for canna, because the canna roots are like a lump, like a gathan ki tarah, like their roots have bulbs. So they have they propagate and their roots require space. So continuous planting area such as this is really nice. So this could take up to almost 200 kg. So one of our team members used it as a board and went ahead, took a ride on the lake. So pretty strong islands. So after the 3 test islands, I think this was the second one. We went ahead and built a bigger one. So this was 2 meter by 2 meter. The structure of this is wooden. You would have seen plies for shuttering, right? Those are pretty water resistant. Obviously, they would rot in the water as well, but they'd still survive for at least 5 years. So we made a structure of wood, finished it with resin, and this is planting holes. The way you see this has 16 by 16 planting holes. So 256 planting holes. And this can take up to 400 kilograms. So this is me actually sitting, like standing on top of the island. So this was a research facility that we'd set up in Bangalore at Bharat Electronics Limited with a partner organization from Bangalore called CDD Society. So we'd set up parallel ponds like this and measure different water treatment efficiency for this. So this was for the first time we took the jump from a smaller islands to a bigger 2x2 islands. Yes, we made another, let's say, variations on this, finished it much better this time. This is similar, 2 meter by 2 meter, 400, 200 kgs with wooden and resin, but this is finished better. So this is at Delhi College. This is at Desai Lake in Delhi College School Indore. This has vetiver grass with that non-poisonous water snake and all. So this was another product, that variant that we built, and kind of tried to finish it better from a marketing point of view. This is the first circular island that we made. Um, so I think someone here was asking how does it float? Can you all see the white part inside the planting holes? So this is basically material made of plastic, often recycled plastic, which helps float the island. So the buoyancy is being provided by this white material that you see inside the islands. The structure, whether of wooden or aluminium, helps keep the island together. The white material helps it keep it afloat. Yeah, so that's what we use to keep it. Someone was asking that. Yeah, so moving on. So this was the first circular island that we made, just 1 meter in diameter. You see the size of this, and even this can take up to 100 kgs of weight. So they planted marigold, genda on top of this. So they had a small well of sorts, a small water body inside their office, CDD Society Bangalore, and they put it there um, using the marigold genda flowers. They later replaced it with umbrella palm. There was this turtle, and it's not very clear in this image, but there's a turtle who would just go and hide underneath the island. So if you move the island from here and moved it to the left a bit, the turtle would come and automatically hide underneath the island. Yeah, so this was our first attempt at circular islands. These are the islands that we made for Sabarmati riverfront. So these are basically 1 meter by 2 meter, roughly 3 feet by 6 feet. We made 6 of these islands. This is the Sabarmati river on the left hand side. And there was a drain coming into the river. So what the Sabarmati Riverfront Development Corporation Limited wanted was, they wanted this drain to be hidden from you. Isko chupa do, matlab. So when you have plants planted on top of it at the mouth of this drain, you can't really see the drain. So that was one of their objectives. The other was obviously the water treatment effect that the islands would provide, and the ecological and the beauty aspects what the floating islands would provide. So this was, I think, our 6th variant that was available commercially, apart from the 3 first islands. And so this island has grown to become very beautiful. All of the plants grew to great lengths. Let me show you a video of, so these are wooden islands. I think the sir from Tamil Nadu mentioned whether they'll be able to withstand flowing water or not. So you see the flow in the river, right? Flow coming out of the drain. So it can easily withstand at least these basic flows. But what we realized was, in the monsoons, the flow might be much, much more than what you see in this video. So we thought that wood would lose its strength over time, right? Wood would rot and its strength would reduce. So maybe we need to move to metal. So all of the islands till now were made of wooden structures. Even this next island is made of wooden. We integrated different kind of planting holes, bigger planting pods, and a planting slit in the same island, and we integrated it like this. This was another product variant. Yeah, I'll come to that river part again. I'll circle back. So this is a custom shaped island that we made. This was for beautification only, strong enough one of our team members. The same team member trying it out, standing on top of it. We integrated solar lights with it to make it beautiful and shine in the night. We tried different flowering species and all. So yeah, so this was one of our islands that was aimed primarily for beautification purposes and not for water treatment. So so we can make it in custom sizes as well. The next one, so this is the first metal island that we made. So the structure that you see on the outside is of iron with epoxy and anti-corrosive paint. So this is a circular metal island that we made. We again used it for beautification, see if it floated or not and how was its performance. We again integrated a few solar lights on top of the island, just for experimental purposes. Tried out different beautiful materials. So that was next product variant. We thought, hey, why can't we make one for aquariums, right? So we made a very small one, 20 inches by 40 inches, had vetiver planted on top of it. And we just put it in one of the aquariums, hoping that eventually these roots would come in from the bottom and it would look really well. So this black material that you see, apart from the roots here, are biomedia. And so the roots have gone through that entire section of biomedia and then come out from the bottom. So another product variant we thought we could have. So anyways, people cover their aquariums, right? So that no bird can fly in or maybe try to eat this fish or whatever. So we thought this could serve as a dual purpose of a lid as well as a natural water treatment tool, because every now and then you would have to replace or replace the water in your aquarium tank, right? Because they begin to turn green. Maybe this could be a natural solution for that as well. Yeah. So this was a second metal island. This we made for Indore Municipal Corporation for the river. So after learning from Sabarmati riverfront experience that wooden islands, that a metal island would be much better in terms of strength for a river. So that's what we did. We made a metal island of this sort with the rings on side of it for anchoring. So this in the office, when we manufactured it, it weighed 200 kilograms. With soil and plants, it weighs about 400 to 500 kgs. That's why we needed a crane to put this in. We had attached chains from all sides and then put it on water. So this is the riverfront development that is happening in Indore. So that's where we installed it. And this can take up to 1000 to 1200 kgs of weight and still float on water. And being made of metal, this would stand the flowing waters in the river as well. As long as we have kept it strongly anchored to the side, it would not go away, because the structure is also strong. If the chains and the anchor are also strong, it would not go away in the monsoons. And we've had 2 monsoons since the time we planted this. Yeah, so that's one of the product innovations that we did for river, to make the islands of metal so that they're strong and that they don't really break. Suppose that, so another, but the problem still persists, right? Even wood would rot, so would metal, right? This might rot after 10 years or something, but it would still rot. So we thought, why not make islands made of plastic or recycled plastic or maybe FRP? So that's what we did. This is basically islands that we installed at Kannamangla Lake near Bangalore earlier this year. So we made 6 islands, again 1.2 by 1.2 meter size, with planting areas in between so that the roots can go in through these slits. We obviously have biomedia underneath these islands as well. So that's what we did. And then the islands eventually grow up and look to be very beautiful. Yeah, so that's what we did. We took the islands there, planted the plants, towed them away with the boat to exactly where they needed to be anchored. And then basically the nature takes its course. Yeah, so that has been our product journey. We made almost 15 types of floating islands eventually over time. So I would also like to show you how the roots emerge from one of the islands. So at this lake that we restored, right? Since we had planting holes, the roots here are pretty less. But this is how they emerge from underneath the water. Thought you'd really like seeing an underwater video with roots. So some of these root lengths measured up to almost 48 inches as well. So the longest root that I measured myself was about 48 inches long, one single root chain. So this is what, this acts like a physical barrier as well, and also like eating up all of the dissolved nutrients and all of that. So that's how the roots emerge from underneath the islands. And obviously the fishes just love it. There. Good food, safety, oxygen, more oxygen near the roots. The fishes just absolutely love it there. Yeah, so these are vetiver grass. The roots of this are basically cut after about 18 months. And these roots are used to make oil. This oil is the ingredient that that goes into khas perfumes, right? So all of you would know coolers during the summer months, right? We put in khas perfume in those coolers. So those are made from the same vetiver grass. So besides water treatment or just supplying and installing a product, revenue could also be generated through certain of these things. That's another dimension to it. Yeah. So let me move on. Let me quickly check if we're on time, yes. Not too late, yes. Yeah, so we've seen this. Right. So I'm sure almost all of you would have kind of understood what floating islands are, how they're made, how we're combining, let's say, civil engineering or structural engineering for the structure of the islands, metallurgical engineering in terms of when we make metal islands, principles from environmental engineering, botany, biofilm engineering as well. We're also looking to integrate a few electromechanical equipments on top of it as well. So besides islands that have just plants, maybe we could make islands that have testing equipment on top of it. Solar powered equipments which would tell you what is the dissolved oxygen in the water right now, what is the turbidity and all of those. And solar powered so that it's self-sustainable. That is one of our ideas for the future. We've already made islands made of metals. We're also including parts of recycled plastic in our islands. Rather than using virgin plastic, we're trying to use recycled plastic. We're trying to make islands that can support trees, right? So we made an island roughly the size of a double bed, that metal one, this one. So this is roughly the size of a double bed, and this can take up to 1,000 kilograms, right? So I'm pretty sure we can integrate trees on top of the islands as well. Maybe banana tree to begin with, but other trees as well in the future. Maybe islands with fountain lights and other aesthetic equipment such as statues or something like that as well. Islands with testing equipments. Islands that can have underwater viewing galleries so that you can go on the island, go underwater without like a completely covered portion around you, but you are underwater and you can see the fishes and the view underwater. I think that could also be one of the great ideas. Besides this, we're also trying to create floating nurseries, right? So maybe cultivate vetiver or some other plants on top of it, which could also help generate revenue. So maybe some kind of cash crops as well. Small islands for aquariums, or maybe even bigger islands that can cover 30 to 70% of the lakes. Maybe in areas, for example, in Maharashtra where water is really a problem, where it rains good for monsoon, but by the time summer comes, the water bodies have dried up. So it can help in reducing evaporation as well. So we are trying to use different ideas as well. So any questions till now? I'll take a pause. I think we just have past last 2-3 slides left. Any questions, anyone? Doubts, suggestions, anything?
Hello. Sir, in your experience, is there any failure by the time of growth of plants with a duration of 1 year or 2 years? So because of plant growth, weight also increases. And is there any sinking of your floating tub like this?
Not sinking, but toppling. What I mean by that is, for example, this island, right? This measures as 20 inches by 40 inches. If something grows on top of it, which is let's say 6 feet tall, right? This is just 1.5 feet wide, and if something grows 6 feet tall on top of it, it might topple. So that is one thing you have to be sure of. For example, islands that are wider would be much stable and they won't really topple. But even this island of ours had toppled once because the plants had grown up to 7.5 feet. You see, this is just 4 feet, the width of this, but the plants are already at almost 5-6 feet and they would grow even taller. So this had toppled once. So then we kind of realized that making broader or bigger islands makes much more sense that they don't really topple. So that is one learning that we've had over time. Yeah. And in terms of drowning, not really, because you see the weights that we have, right? We're taking a lot of factor of safety. Whatever happens, our island should not drown. Because over time, the weight of the plants grow, their weight on the island increases. Often someone would go and stand on the island, etc., etc. So we ensure that we make islands so strong that they don't really drown. We have that much factor of safety. We ensure we take that much factor of safety. Does that answer your question, sir?
Okay.
So there's a question in the chat box that during summer, what if the root gets anchored?
Yes. So when the water body runs out of water, it can't float, right? It go and settle and sit on the bottom of the lake or bottom of the river, stream, whatever. The roots might take might kind of try to take hold of the soil underneath. But remember this, under a water body, the soil is always very muddy. It's not solid. It's always muddy. So even if the roots take hold of that, whenever the water comes in back again, it floats, right? Because the buoyant force on top of it is about, let's say it's 100 kg or 500 kgs is trying to bring it up because of the buoyancy force. Even if one or two of your roots take hold, you can either cut it or it comes up naturally, because the buoyant force is so strong, it can't really keep itself attached to the bottom of a few roots might touch and go unattached, but as the water fills in, it automatically comes up. That is one of the reasons why we had to make our structures so strong, right? Because if the water disappears and it goes and sits at the bottom of the lake, there may be rocks. It might be sitting awkwardly and in an angle on top of one of the rocks. So the island should be strong enough to bear the brunt of this. And even if the roots attach, the soil is very, excuse me, the soil is very muddy. It's like mud and very swampy underneath the water bodies. Even when the water disappears, it would stay muddy for at least 1 or 2 more months. So then not a problem. It really does not get attached that strong, and it can come up again on its own. Yes. Any other question? I'll move on. Yes. So in terms of how we're going about it, yeah. So what we're doing is, besides direct sales, like anybody who wants to buy floating islands can contact us directly, and we have a distribution channel to supply to the government. So these are 2 major revenue streams. But I think I would really, really like to bring your attention on this PPP model. So a PPP model, or a public-private partnership, or a BOT, build, operate, transfer model, is something that we're trying to work on. So please don't look at the photos right now, and just bring your attention to what I'm saying, right? So for example, when government has to build highways, right, and it does not have the money, what it does is it invites private contractors to come in, who put in money from their own pocket, builds these highways, and then they recover their money through toll booths over 5, 8, 10 years, whatever. So this is an example of BOT, or public-private partnership, right? What if we could adopt a similar model for restoring water bodies, right? Imagine I could approach Indore Municipal Corporation, or any government for that matter, and tell them, hey, you want to restore water bodies, you don't have a budget, no problem. I will put money through my own pocket, restore the water bodies, put in floating islands, aerators, plants, benches. I will restore the water bodies myself by putting in the investment through my pocket. And I'll try to generate revenue through multiple sources and kind of recover that investment. Maybe for 3 to 5 years, I can recover the investment and transfer it to you in a BOT kind of model. Or me and the government could get into a revenue sharing model, 50-50, 80-20, whatever the financials number work out to be. So this is one of the designs that we made. So this is the direction we were really heading towards, right? Because we used to make islands and then supply to the government and wait for the governments to buy. But post-COVID, government does not really have the funds. For restoring water bodies anyways used to be in the last priority list. Post-COVID, they say, hey, we have no funds. So what do we do? So that's why we wanted to innovate and say, hey, if the government has no funds, no problem. We'll put in the funds. And then we'll restore the water bodies. That is primary. And then maybe recover our investment through different things, right? So we could use the same wetland plants. So this is what we created, 1,000 square feet island with a 250 square feet middle area and 750 square feet of plants around it. So it would help clean the water, beautify, restore the ecology. So it's good for the lake. And what I want to do is basically I want to monetize this 250 square feet in the middle. So maybe if I put in a floating car and ask for advertisement fees from the car company, or maybe let people take pre-wedding shoots, or let them do yoga or an exercise on this, right? This could help me monetize it. So advertisement, maybe tourism could be one way. So maybe taking tickets for people to enter might not be the best idea, but maybe a possible revenue source. Boating is one way how we can commercialize and recover our investment to restore the water bodies. Fishing could be one way. Maybe establishing a plants nursery. So we have a lot of buffer zone around the lakes, right? So all of these could be used to propagate plants and maybe make a nursery to cover the expenses. The caretaker who would take care of the island on the nursery could live at the lake itself. Sorry, is there any question?
Yes, anybody would like to speak to sir? Probably there was a disturbance, sir. I would like to add that you can even make a floating restaurant over it. People would love to have it.
Yeah, a floating restaurant could also work. Maybe if there was a underwater gallery here, right? I could put an inverted dome at the center part where you could go inside the dome and see different ideas, right? Just so we're trying to work towards this. So because the government isn't really buying right now, and if we could do this right, let me cover the other commercial aspects how we could do that. Besides the plants nursery, we maybe could grow seaweed, right? So seaweed grow like creepers, or Hindi mein jo bale bolte hain. So those would grow vertically and go downward in the water. They grow underwater. Those could be grown. I mentioned vetiver or other kinds of farming. Oysters can also be grown underwater. So monetize through any way that is acceptable to the government, to the community, and also does not harm, but only does good to the water body. So a lot of these ways we can monetize it. And imagine this: if we are able to, what I have to do is basically I have to balance the two sides of the equation: cost of setting up floating islands and the maintenance, annual maintenance. I generate revenue I can generate yearly, right? If I'm able to kind of get that payback period down to 3 years or something, believe me, I think we would have won the global battle for restoring water bodies, right? Because then the government needs absolutely no funds. I could go to, let's say, I could go to any city and say, hey, give all your 25 lakes and 4 rivers on lease to me. I will ensure they stay restored, the water stays clean. And through private funding, these water bodies can be restored. So that is one way that is one direction that we're trying to work towards. I think if you're able to crack this model, we could win the global battle for restoring water bodies. So that is one thought that we're working on. A thought would share this with you because the audience present here today are very elite, right? You come in from different fields of science and engineering. I might have breadth of these engineering fields from biomedical, like biofilm engineering to civil to structural. All of you are experts in your respective fields. A lot of suggestions can come in, a lot of ideas can come in from you. So I would really like to hear from you of what you think of this and the entire presentation of product in general. So thought we would share this as an idea for the future. Thank you. Yeah, so I'd like to invite questions, suggestions, anything.
That was a very wonderful session, sir. I'm very inspired by the work you have done. The journey was wonderful, and the way you narrated it was very eye-capturing. It was like a story you told about yourself. So that was very nice, and we all are very fond of stories, whether people admit it or not. We are a child at our heart still. So that's a wonderful thing. The way you have told it, that was also awesome. We thank you, sir, from the proper bottom of my heart that you accepted my request, that you took time out of the schedule and you came online. The weekdays were a bit challenging, but you accepted on the weekend. Thank you so much, sir, for devoting your time, and the way you have worked is very inspirational, sir.
Thank you. Thank you for this opportunity, ma'am.
Thank you so much, sir. As of now, I don't find any question in the chat box, but a lot of comments. The one thing which a participant has asked is, are there any non-government project sponsors? I will request to share any one challenge you faced to convince.
So I have only received 2 government projects till now. All of the others have been private projects funded through CSR funds, right? The lake that I mentioned, this Kannamangala Lake in Bangalore, this is funded through CSR funds, corporate social responsibility funds. This is a government project from Indore Municipal Corporation. This is another government project for Sabarmati Riverfront. for these projects, these are private schools, private research facilities. So that's the problem that I'm actually facing, right? Working with the government, because this is a relatively new product, right? Most people don't really know about floating islands. First, I have to educate them as to what this is, what benefit it would give them. Then it comes to, okay, kahin lagaya hai, kahin tender nikla hai, have you implemented anywhere? Because for any government body to be the first to do this, it might raise questions on them, right? It makes it much more easier for them if a tender or a work order was issued somewhere. And so working with the government has its own issues, right? Let me not get into most of the stuff, but let's say making a tender, drafting the tender, and since only a few companies in India are doing this, and like just 4 to 5 people in India are doing this, and less than 20 people worldwide. So you don't have competition. You might have to put in dummy companies of your own, or another problem with working with the government is the payment terms. So being manufacturers, we only work on 100% advance, and the government really does not give advance. So even that is another issue. Okay, don't give us advance, but please, the government should at least ensure that they pay us on time, right? If we supply to the government, you might not get payment for 6 months, 12 months, 18 months. Even then, you might get part payments. So not the best. I think that is one of the challenges to work with the government. And since this is a primarily B2G sector, we have no option but to work with the government. So maybe we're trying JM portals as well, government e-marketplace and other things. I know it will be a slow start, but once people realize the benefit of this, see this in Indore and other places, this will pick up. I know it is a few months, a few years down the line. But anyway, so I told you, right, water body restoration is still in the R&D phase and still very early. I expect it to grow really well in the times to come.
Thank you so much, sir.
Most
That
of our
was
projects
really
have been-
wonderful.
Yeah.
Very wonderful. And at the tender age which you have grown, that's very inspiring, sir. And we look forward to you. We hope to see you personally in future sometime. Thank you so much, sir, for the wonderful session, and thank you.
Thank you.
From all the participant side also, they have complimented, sir, that it was a wonderful session.
Great. So I think I'll stop sharing my screen and look at the wonderful comments that left.
Thank you, sir.
Sir, I
Good.
would like to remind you that we were supposed to share the heavy metals and some specific plants, or if you could share.
Yes, sir. Ma'am, you have his email address. You can directly contact him. And he would definitely love to share the information.
Brother Priyanshu, I would like to congratulate you. This is a really wonderful session, and I will be personally contact you. And very soon we are arranging one webinar on. I would like to invite on that personally. Thank you very much. I must have to congratulate. It was very wonderful, nice one. Thank you.
Thank you so much. Looking forward to it. So I'm posting my email address and phone number again in the chat. Those of you who would like to maybe personally get in touch with me can do that.
Yes, sir. I got it. Your email address. I'll be contacting soon.
Okay.
Good morning, Vimal, sir.
Yeah, very good morning. Now I'm ready to discuss.
Sir, shall I introduce you and then we'll be proceeding with the session?